So hi, welcome to the first episode of our blog series. If you didn't know, we have a blog every single week on our Oscilloscopes blog. There's a link for that in the description, or if you just Google Oscilloscope blog, you'll come up right to our blog post. And what we're going to do is we're going to sit down with the authors of each of those blogs every week and talk about what their blog is. So if you're not into reading blogs, or you want to hear directly, from the voice in the mouth of the authors about their blog, you can watch this video instead or in addition to that. So we're going to cover pretty much all of the information we talked about in the blog. So today we have Eiley Grumbine and Brad Dorr. Brad Dorr is our R&D engineer, and Eiley, I don't remember what your title is right now. I know it changes all the time.
Yes, I'm the strategic planner for the Internet Infrastructure team.
Okay, awesome. So she did DDR, so you may have seen her on our YouTube channel back in the day for some DDR type stuff.
Yes.
But today we're talking about data analytics for the design to manufacturing process and design of experiments. So can one of you guys give me a little bit of the overview about what that looks like?
Yeah, so in an engineering firm, the design to manufacturing process usually involves typical sequential process from design to manufacturing, and each stage actually involves some format of a data collection.
Sure.
And these data collections are really predetermined by design of experiments, and it's aimed at to meet certain critical requirements in order to release the design to production. So
basically you have your R&D engineers designing a product, but that still has to get manufactured. So
yes.
There's more or less like checkpoints you have to get yourself through, measurements you have to make and quantify over time.
Yes.
Make sure you're on the right track.
Yes, true. So Brad, maybe you can walk us through like each stage of the design to manufacturing process and how the effective data analytics tool can actually help these designers.
Right. So first of all, in the design stage, we have a requirements document. Any company will have a design requirement document, and that lends itself to building a design of experiments. So if you have, let's say, a bandwidth and a bit rate or a bit error rate that you're designing to, and there's usually a lot of different specifications, especially when you get to like a DDR4 interface built in or PCI Express. There's a lot of parameters that you're going to have to meet. So you make a design of experiments. It's a well-known technology,
okay.
And that lends itself to figuring out what data you need to capture both in simulation and empirical characterization and validation testing. And if it's done right, then those things all contribute to a data repository and enable analytics.
Okay. And a lot of people, my understanding is they're kind of just using like Excel pivot tables or homegrown tools, or there's some options out there that are just so highly complex that maybe only one or two people in the building really know how to use it. Is that true, or is that?
Yeah, this is what we found. Eiley and I have met with many tier 1, tier 2, tier 3 customers, companies involved in this, and no two are the same. All of them share a number of issues that we tried to describe in the blog posting, but in a nutshell, various tools that can work, but a lot of times they're only understood by one person on the team. I heard one executive say, if our expert doesn't show up to our staff meeting, we can't make decisions. If we don't have all the data, we don't have confident decisions, etc. And so that's the problem we're really trying to attack in this article.
Okay, can you maybe outline a couple of what those problems might be that people are dealing with?
Yeah, so a lot of these tools, homegrown tools, they're not really tailored for the test and measurement world.
Okay.
So, for example, in an engineering firm today, like everyone has globally distributed team.
Sure.
So everyone needs to be able to contribute to the data and also ensure that, and managers should want to ensure that they have enough information, complete information to make a decision on their design.
Okay.
So, like first thing is, the challenge is how do you gather all this data from the globally distributed team?
Right.
And the second challenge is, a lot of these homegrown tools, only one person know. So usually a steeper learning curve.
Yeah,
so,
it's like some guy down the hall wrote it and it's cubicle, and it's kind of like, oh yeah, you have to hit these weird buttons in this order. Or else,
right. Yeah. Even a readily available application today, like you still need some kind of learning curve, to
Sure.
be able to operate and be able to use all the function, effectively. So, the effective data analysis tools have two components. Basically, the repository needs to be available. Everybody needs to be able to access and retrieve the data.
Okay, so everyone needs to be able to get to it.
Get to it, yes. And then the second thing is, it has to have this modern visualization tool that it's useful for the test and measurement work,
Sure.
like a sweep plot, histogram plot, line charts, scatter plots, yeah. I think that's
Okay.
it.
On top of that, though, I think a key point that we've learned in all of our customer engagements is if that tool isn't easy enough to use that the entire team can engage, then you're making decisions based on the opinions, the analysis of only a few, or maybe just one person on your
That
team.
makes sense.
We had one example that that one of our colleagues encountered, which was an executive who made a decision based on a strong recommendation from one of the guys on the team, not realizing that this guy was an expert on most of the requirements of the project, but not all of them. They ended up fabricating an ASIC that did not meet all of the specs. And the real issue is the whole team wasn't engaged. And that's why the best analytics solution has very simple access. Not
Sure.
the kind of application you're afraid to jump into, the one that you can just go to and it's easy to use and you can have team meetings on the fly.
Sure. So you either have to have a very, very simple program that, maybe an Excel sheet that's not, tabs and tabs and tabs of data and pivot tables, but a couple, key spec chart type things, or a program that's going to be, accessible for everybody and hide all that background and stats stuff.
In today's global environment, it's doubly important.
Okay. And I was looking at some of the screenshots. So we're looking at the N8844A. It's a Keysight software product. You mentioned scatter plots and whisker plots, so I'll pop a couple of those up on the screen. Can you maybe explain what we're looking at on those charts? So maybe start with the scatter plot.
Right, so the first plot is a constellation diagram. So it's a 5G for constellation diagram.
Okay.
So there's three sets of constellation data overlaid here. It represents three input voltages, 1 volt, 0.9 volt, and 0.8 volt. So now the plot reveals that the constellation diagram with input voltage of 1 volt has the cleanest transmitted symbol.
Okay.
So the constellation diagram with input voltage of 0.8 volt seems to have a lot of phase noise issues. So it might be presenting a signal quality problem with that if you use an input voltage of 0.8 volt.
Okay. So along the go ahead, sorry.
Overlaying these things is the real key. And Eileen's talking about just one parameter, but many times, in fact, every DOE I've ever seen before has maybe 10 or 20 or 30 different parameters.
Sure.
And what Keysight's N8844A application allows you to do is figure out which one of those parameters, in this case, Eileen's identified the smoking gun,
Sure.
but there are a lot of other parameters that don't really affect that or affect it in different ways.
Okay.
And it's the ability to visualize these things superimposed and then split and filter off of them that produces the analytics.
Okay, so you say my phase noise is through the roof. I'm having problems. You want to go through all your different tests and try
Test
and figure out
station,
what's going
input
on.
voltage, software version, antenna physics, etc.
And then you have I don't remember the name of this plot. It's like a box and whisker.
Yeah, box and whisker plot. So it's a very famous plot that people use in the test and measurement world. So this figure actually shows a jitter measurement with multi-level split capability.
Okay.
So now the user can split on one properties, and so for example here the property on the plot on the left is actually split by 3 username. Somebody
Okay.
is making that measurement, and then the property on the right is split on another level, which is username and input voltage.
So you can see if different engineers are testing differently, and that's why they're getting different results.
Yes.
That's pretty cool.
When all the data is stored in one repository and stored in an orthogonal fashion, then all of this kind of analytics is available without a complex GUI, without 15 different drop-down
Sure.
boxes.
Yes.
We tried to make it easy enough that even Eileen could use it.
Or me. I'll have to give it a try later.
Mhm.
So I think that wraps up. Is there anything else on the blog that you wanted to cover in the video today? I think we kind of hit all the high points
There's some
there.
additional details, but these are the highlights.
Okay, so if you'd like to learn a little bit more about this and about data analytics and that challenge as a whole for your design of experiment, check out the blog. The link for that's in the description. We're also, I think, going to have Brad back on our EEs Talk Tech podcast to talk a little more about data analytics as a whole. So stay tuned for that and check out the podcast. We'll also put a link for that in the description and probably in an end screen or something like that. Any closing statements? Thank you guys so much for being here.
Gotcha.
Eileen, we finally got Eileen, on the Oscilloscope channel.
Yes.
Maybe we'll have her come back by DDR on the podcast too.
Sure.
Sure. Oh, okay, we got a commitment, so we'll have her back. That's all. Make sure you subscribe to the Keysight Oscilloscopes YouTube channel. Go check out the Keysight Oscilloscopes blog. You can also get email reminders from the blog when a new blog posts. We generally have one every week on a Wednesday. And that's all. Again, Brad Dorr, Eileen Grumbine, thank you guys so much for being here. And I'm Daniel Bogdanoff, and we'll see you next time.